So I changed my mind and decided to do this today because after I do this one podcast, I'll be all done. And this is actually not going to be that long because I'm going to do just 2 examples on initial condition and go through the list of integrals for you. And then I'll do a couple more examples in class. So this is the last podcast. I'm going to do this break. All right, so finding a particular solution. So when we take the antiderivative, we don't get a single solution, right? We get a family of solutions, right? We get the antiderivative plus c, plus that constant. And we have no way of figuring out our constant unless somebody gives us a little help, gives us some helpful information that helps us find the value of c. All right, so we've been finding what's called the general solution, the general antiderivative. It's the family of functions that all have that function as its derivative because the constant value isn't going to matter when we take the derivative because the derivative of a constant is 0. If we're given some information about our function, and specifically we need to be given a value. We need to know some value of x and y. So, for instance, here, if f of 1 equals 0, that means we have a point, right? So when x is 1, so this is the x and this is the y, right? F of 1 equals 0. That means when x is 1, y is 0. So that is a point. If we have a point, then we can solve for our constant. Okay. So here I have an example. It's already up here, and I'm going to do an example with you. So here we're given the derivative of, our derivative is 1 over x squared. So that means, in other words, we want to take the integral of x to the negative 2 dx. When we take the integral, right, we increase the exponent by 1. So then this would be negative, our integral would be x to the negative 2 plus 1, and we divide by that same value. This is just the power rule. So we have our function is x to the negative 2 plus 1 divided by negative 2 plus 1, which gives us negative x to the negative 1 plus c. Okay. Oops, I just threw the pen. That would be our function. So that's what that loud crash was. That was me accidentally throwing the pen. I didn't mean to. That's our general solution. That's the family of functions. So the family of functions that has x to the 1 over x squared or x to the negative 2 as its derivative is negative x to the negative 1 plus or minus some constant. If we're told that when x is 1, y is 0, we can solve for our c here, our unknown c. We just replace f of x with our y value, and we replace x with our x value. Okay? So in other words, we just set it our antiderivative here equal to 0 and plug in 1 for the x. So I have it written down below, but I'll solve it as well because I think it'll make it clear. So we have, let me just write the function there. So we have f of x equals negative x to the negative 1 plus c. So I'm just going to replace that. Actually, let me not write it as a negative. Let me write that as 1 over x. As negative 1 over x plus c. So now I'm just going to replace the y, or the f of x, with 0. So 0 equals negative 1 over, and I'll replace the x with 1 plus c, and we'll solve for c. So so this is just 0 equals negative 1 plus c, add 1 to both sides, and so 1 is c. Which means our particular function is sort of hidden by my work there. And I'll put it in blue. So our particular function is negative 1 over x plus 1. That's the specific function, okay? Given that it has to go through the point 1, 0. Okay? So it really is not that hard to find the specific function, because you're just plugging in for x and y and solving, and it's usually a really easy solve. The harder part is finding the antiderivative. But so far it's really not that hard. I hope it's not that difficult. I hope it makes sense to you. So we want to find the equation of the curve that passes through 2, 6 if its slope is given by dy dx equals 3x squared. So if dy dx is 3x squared, if you want to go back to the function, you just integrate. Okay, so we take the integral of 3x squared. I think you've even seen this one. 3x squared dx. Okay, so we're going to integrate that. All right, so this is just the power rule. So I'll write it down here. So we have the integral of 3x squared dx would be, and I can, if I like, I can factor out the 3. So I've got 3x squared dx, and so I increase the exponent by 1, and I divide by that same value plus a constant. So that's just 3x cubed divided by 3 plus the constant of integration, or x cubed plus c. Okay? So that's our this is our general antiderivative. The family of functions is x cubed plus c. We want to find now the particular solution. And we can find the particular solution because we're given the fact that we have this point here, 2, 6. So we just plug in the 2 for x and plug in the 6 for y and solve for c. It's that simple. Okay, so we've got, so my function here, f of x equals x cubed plus c. So 6 equals 2 cubed plus c, and 2 cubed is 8, so 6 equals 8 plus c. Plus c. I'm thinking of subtracting 8, so I accidentally put a minus there. Plus c. And so we subtract 8 from both sides, and negative 2 equals c. So now that we know what c is, we can write our particular solution. We'll put it in red. So our particular solution is f of x equals x cubed minus 2. There's our particular solution. So you see that's not very difficult at all. Right? So in class, this is going to be a short podcast. That's okay, I did a lot long ones. In class, we'll talk about this revenue function, and because we were looking at optimizing, so we'll take a look at this one in class, and this other real world one in class, and we'll do a few more problems. But what I wanted to look at just real quickly with you, and I'll post this on the Google Drive, is some list of antiderivative rules. Okay, just like we have the derivatives. We had this is how you take the derivative. These are the rules. This is the rules for the antiderivatives going the other way. Okay, so the integral for the antiderivative for dx would just, so the integral of dx is the same as 1 dx, and that is the power rule. That would you're just going to increase, that's like x to the 0, so you'll increase that by 1 and divide by 1. So the integral of dx is going to be x. And of course, these are all the indefinite, so we have to have plus c. If we have k dx, there's a coefficient in front of dx, then it's going to be kx. Okay? So we're going to multiply, that's just our constant multiple. We're just going to multiply that times our integral plus c. If we have x to the n dx, that's just the power rule. So we'll increase the exponent by 1 and divide by the same thing, plus c. The integral of cosine x is sine x. The integral of sine x dx is negative cosine x, because we know the derivative of cosine x is negative. So if the answer is positive, the integral's got to be negative. The integral is secant squared x dx is just tangent x, because the derivative of tangent x is secant squared x. And there are a couple other ones up there, and they are just our common ones. So cosecant squared x, the function that has cosecant squared x as its derivative is negative cotangent x, because the derivative of cotangent x is negative cosecant squared x. We saw a secant x tangent x, so the integral of that would be secant x, because the derivative of secant x is secant x tangent x. If we have there is something missing right here. That's why I stopped for a second. What the heck? By the way, I did not type the list because it's a lot of work for me to put this into, I have to put this in a format. I can actually type it in looking mathy, but they have an error there. So cosecant cotangent, who has cosecant cotangent as its derivative? Well, it's a lot like the one above it. It should be negative cosecant x plus c. So that's a typo, and let's make that a right function there. Because if we take the derivative of cosecant x, we have negative cosecant cotangent x. So if the integral is positive, then the antiderivative must be negative. This is just the power rule. This just goes together. That's just the power rule with a coefficient. They're the same things. You can factor out the k, and then it's just a power rule. Of course, e to the x is its own, and 1 over x is just natural log of the absolute value of x. And the only one not up here is b to the x dx, which would be the same thing divided by the natural log. Oops, I've got 2 in my head, I guess. Natural log of our base plus c. Okay. So there we've got everybody. So there's a nice list of our integrals, and actually that will get you quite far. These are all the common ones. After this, it takes a little bit of working with and maybe simplifying, like you saw in some of the lessons and problems that I've gone over. Okay, so I hope this is making sense. Really, all we are doing is undoing taking the derivative. We're just going the other way. And the only thing that happens is we're really not sure what the constant was, because you take the derivative and it's eradicated. It's 0. So there could have been a constant there we don't know about. So because of that, we always include our constant on these indefinite ones. Right? And that's it for me. So if you have questions, let me know in class, email me, whatever. See you soon. Bye.